Today's lesson is on 3x3 systems. By the end of the lesson, you should be able to solve a linear system involving 3 equations algebraically and using technology. Systems of equations, or more than one equation, arise frequently in mathematics. To solve a system means to find all sets of values that simultaneously make all equations true. Of special importance are systems of linear equations. So the first 2 examples should be review. The first way we're going to do it, part A, is by substitution, and we are literally going to substitute one equation into the other. So you want to look at both equations and see if there is a variable that is easily isolated. So in the first equation, we have 3x and 2y. That means I'm going to have to either divide by 3 or divide by 2. Not so easy. But I notice in the second equation, I have 2x and then y. So it's very easy to get y alone. So that's what I'm going to do. So I'm going to have y equals -7, and then I'm subtracting 2x over. And those are unlike terms, so I cannot put them together. So I now know the value of y. It is -7 minus 2x. So y in the other equation is going to become -7 minus 2x. So I have 3x plus 2 times y. Well, y is -7 minus 2x equals -9. And the big dilemma in systems of equations is you can only solve an equation if it has one letter in it. So we have 2 equations and 2 letters. So we have to somehow figure a way to get an equation with only one letter. So we use substitution to do that. So now I have one equation with one letter, so I'm going to do my math. So 3x plus -14 minus 4x equals -9. I'm going to combine like terms. Those are on the same side. So 3x minus 4x is -1x. Minus 14 equals -9. Add 14 to the other side. So -1x equals 5. Divide by -1, so x equals -5. Well, the problem is I have 2 variables, x and y, so I still have to find y. The good news is you can pick either equation, the first one or the second one. I think the second one's easier. So 2x plus y equals -7. Well, I know what x is. X is -5. So we have -10 plus y equals, and I screwed up over here, this should be a -7. So when I add 10 over, y equals 3. So my answer, and I'm going to write it as an ordered pair, x comma y, is -5 comma 3. And I could store -5 for x in both equations and 3 for y in both equations, and it better make all the equations true. Okay, if it doesn't work in one of them, it's not true, it's wrong. So in part B, we're going to review elimination, and that means you're going to use multiplication to eliminate one of the variables. So again, it's about looking and analyzing. So in order to get rid of the x's, if I add these together, I would have to multiply this one by 2 and this one by 3 and then make one of them negative. That's kind of hard. That's a lot of work. And I'm not about a lot of work. So I noticed, look at the y's. 2y, 1y. So if I multiply this one by -2, look what happens. The first one stays the same. But look what happens to the second one. -4x minus 2y equals 14. Now when I add these together, I get -1x equals 5. It's just a coincidence that it's the same as over here. So you want to try to, in elimination, add the 2 equations together and have one of the variables drop out. Sometimes you have to multiply one equation. Sometimes you have to multiply both equations. Sometimes you don't have to multiply any. You could just add them together. So you have to be able to look and analyze before you jump in and do some math. So again, x equals -5. So again, I'm going to plug it into one of the equations. I'm going to use the same one. Actually, I'm not going to use the same one because I'm going to prove to you that it works with the other. So 3 times -5 plus 2y equals -9. So this is -15 plus 2y equals -9. So let's go back up here. So if I add 15 to both sides, I have 2y equals 6. So y equals 3. Well, look at that. So my ordered pair is -5, 3. So you'll notice it's the same in both. So I have the right answer. So when you have we call this a 2 by 2, 2 variables, 2 equations, you can use substitution or elimination. It does not matter. In this class, we will be doing 3 by 3s. And you will only have one choice to solve, and that is called elimination. So you should be familiar with solving 2 by 2 systems of linear equations, 2 equations and 2 unknowns. In this lesson, we will extend the method of elimination to linear systems of 3 equations and 3 unknowns. These linear systems serve as the basis for a field of math known as linear algebra. So let's look at exercise 2. And it looks, holy cow, scary. But if you're good at algebra, you'll be fine. Okay? And you just have to be organized and do things methodically. So this tells us the addition property of equality allows us to add 2 equations together to produce a third valid equation. So that's what we did in elimination above. Create a system of adding equations 1 and 2 and 1 and 3. Why is this an effective strategy in this case? Well, let's look. 1 and 2. So we have 2x plus y plus z equals 15. And be very careful with z's. Sometimes they look like 2's. And then we have 6x minus 3y minus z equals 35. And then it said 1, so 2x plus y plus z equals 15, and 3, -4x plus 4y minus z equals -14. So what happens when I add them to create a new equation? Well, I get 8x, 1y minus 3y is -2y, the z's cancel, equals 50. So this was effective because z canceled. Let's see if it happens here. 2x minus 4x is -2x. 1y plus 4y is 5y. Z cancels, and it equals 1. Sweet! Now I'm back to what we did above. 2 variables, 2 unknowns. So z was eliminated. That's why this was a good deal. Okay? That's why we did it this way. Please, please, please do not think that you're always going to take equation 1 and 2 and 1 and 3. You have got to assess the situation before you start, always. So use the new 2 by 2 to solve. So we have 8x minus 2y equals 50, -2x plus 5y equals 1. So what am I going to do? Well, I noticed these are already opposites. So if I multiply this one by 4, 4 times -2x is -8x. When I add them, they'll be gone. So I have 8x minus 2y equals 50. And now I have -8x plus 20y equals 4. The x's cancel. So -2y and 20y give me 18y equals 54. Divide by 18, so y equals 3. One of the 3 variables we have defined right now. Now we got to find the other one. So I'm going to use which equation is easier. Kind of looks like they're the same. So 8x minus 2y equals 50. 8x minus 2 times y is 3 equals 50. 8x minus 6 equals 50. Add 6, so 8x equals 56. So x equals 7. All right, we're 2/3 of the way there. So now we need to find z. So I'm going to go back to the original, and I think the first one looks the easiest. So we're going to do 2x, well x is 7, plus y, which is 3, plus z equals 15. So 14 plus 3 plus z has to equal 15. 17 plus z equals 15. Subtract 17, so z equals -2. So here's our variables, x, y, and z. So when we write the ordered pair, we write x, y, and z. So x is 7, y is 3, crud. I got so excited, can't close the parenthesis, and z is -2. Now close the parenthesis. So a 3x3 has 3 variables in the parentheses. This is a huge algebraic question, and it has a huge amount of work to it. So you've got to be meticulous and organized. Just as with 2x2 systems, sometimes 3x3 systems need to be manipulated by the multiplication property of equality before we can eliminate any variables. So in exercise 2, by adding 1 and 2 and 1 and 3, z canceled without doing any multiplication. Well, this one is going to be a little bit more difficult because we have to look at which variable we can get rid of. Well, right away I look at the y's because I have a positive y and a negative y in 1 and 3. So I'm going to take, hold on, I probably should read the question first. Which variable will be easiest to eliminate? So I just said y's because they have less variables attached. So y, because less, not variables, coefficients, those are called, attached. And coefficients are numbers. So use the multiplication property of equality and elimination to reduce this system to a 2x2. So we're going to take, I'll call this one 1, 2, and 3. We're going to take 1 and 3. So 4x plus y minus 3z equals -6. 5x minus y minus 7z equals -19. Notice y's cancel, so 9x minus 10z equals -25. Okay, so now we have to use 2 more equations and get rid of y. So I'm going to use 2 and 3. And the reason I chose 2 and 3 is because I have a positive 4y and a negative y. So if I multiply this one by 4, they'll be opposites. So when I add them together, they'll be gone. So I have -2x plus 4y plus 2z equals 38. 5x minus y minus 7z equals -19. I cannot add them. They will not disappear or eliminate. I must multiply this one by 4. So -2x plus 4y plus 2z equals 38. 20x minus 4y minus 28z equals 76, and it's negative. So now 18x, y's cancel, minus 26z equals -38. So now I can use this one and this one to solve the 2x2. So 9x minus 10z equals -25. And 18x minus 26z equals -38. I can't add them together, nothing's going to eliminate. So what can I multiply? Well, let's look at the x's. Isn't 9 times 2, 18? but it needs to be the opposite, so it needs to be negative. So I have negative 18x plus 20z equals 50. 18x minus 26z equals negative 38. X's cancel, so I have negative 6z equals 12. So z equals negative 2. Now I have to find x and y. Well, I go back to this equation and I can find x. So 9x minus 10z equals negative 25. So 9x minus 10 times negative 2 equals negative 25. 9x plus 20 equals negative 25. 9x equals negative 45, so x equals negative 5. Whew! We're almost there, and you'll know now why you had the whole page. So now we have to find y. So I have to go back to the beginning to find y. So I'm going to use the first equation, 4x plus y minus 3z equals negative 6. So 4 times negative 5 plus y minus 3z equals negative 6. Oops, forgot to put my negative 2 in. So this is a negative 2. So we have negative 20 plus y plus 6 equals negative 6. These are on the same side, so what's negative 20 plus 6? Negative 14 plus y equals negative 6. Add 14 to both sides, so y equals 8. So I have x, y, z. So x is negative 5, y is 8, z is negative 2. Done, algebraically. Now I'm going to show you, and you're going to be really mad at me, because after 17 minutes of video, you can plug it all in the calculator and get the answer. But if the question says to solve algebraically, and you plug it in the calculator, you will not get full credit. So please make sure you know how to do it algebraically and use the calculator to check your work. So grab your calculator. So you need a calculator page. So you are going to go to the menu, Algebra. We are going to solve system of linear equations. And you'll notice that you could have done this with a 2x2. So you can do this with any set of linear equations. 2x2, 3, 4, 5, 6. Holy cow. So we are going to hit the up button and say it's a 3x3. Then when we go down here, notice it adds the variable z. Okay. And we just have to plug them in. So we're going to plug in the original. So 4x plus y minus 3z. And your equal sign is below your control button, so equals negative 6. Then you're going to put the next one in. Negative 2x plus 4y plus 2z equals 38. And the last equation, and calculators is only as good as the person typing it in. If you type it in wrong, you're going to get the wrong answers. So minus y minus 7z equals negative 19. All you have to do is hit enter. And negative 5, 8, negative 2 matches what we got. So go back now and plug in the second exercise and the first exercise to repeat this process on the calculator. Menu, algebra, system of linear equations, however many variables you have, 2 or 3, and then plug the equations in. If you have any questions, please ask in class. Good luck.